Hello, everyone. Good morning, dear authors and invited guests. Welcome to Technical Session 7C. Myself, Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Solistic LLP, it's my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2024, Jaipur, India. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held a day before yesterday in Jaipur, India, and the virtual event is being held through Zoom yesterday and today, that is 20th and 21st December 2024. I hope you will enjoy the knowledgeable interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for presentation and 2 minutes for question answer. On 7 minutes, I will raise a gentle reminder. There is another request to all the participants to stay connected with us till the closing remark. If you have any query or any update, you can write it to me in the chat box. So before moving forward, I would like to introduce you with today's session chair, Dr. Deepak Mane. Dr. Deepak T. Mane is currently working as Associate Professor in Vishwakarma Institute of Technology, Pune, India. He has 17 years of teaching experience. He has written books on machine learning, fundamental of programming languages, and principle of programming languages for computer IT students. His main area of research focuses on machine learning, deep learning, and supervised clustering. I request Sir to kindly address the participants.
Okay, good morning. Good morning, all participants, and best wishes for your presentation. And I eagerly waiting for your presentations. Okay, thank you.
Thank you, sir, for motivating our participants. Now let's move towards the first presentation of the day. For first presentation, I would like to call K. Radhika for the paper title, A Comparative ML Approach for Early Prediction of Cardiovascular Disease. I request the presenter to kindly proceed with their presentation.
Good morning, one and all. Myself, Radhika. I'm going to share my presentation.
Yes, ma'am, you can proceed.
Yes, sir.
Yes, ma'am, your screen is visible to us. You can
Yes.
continue.
Okay, thank you, sir. So, my title is A Comparative Machine Learning Approaches for Early Prediction of Cardiovascular Diseases. My outline is I'm going to cover these are the contents, introduction, abstract, methodology, results, and conclusion and the feature scope. Introduction. Cardiovascular diseases are the group of diseases that affects the heart and the blood vessels. So these are the disorders such as coronary artery disease, heart failure, and a stroke. So, according to the World Health Organization, estimated 17.9 million people has been dying every year due to the primary cause of unhealthy diet, unhealthy habits, lack of physical activity, tobacco consumption, and high hypertension and high cholesterol levels. These are the some of the primary risk factors which significantly increasing the development of cardiovascular diseases. There are several treatments and diagnoses are available for cardiovascular diseases, but early diagnosis and detection are crucial in managing and reducing the burdens of cardiovascular disease. In spite, there is a significant progress in the current research for predicting and diagnosis of cardiovascular diseases. There are several limitations that need to be addressed to improve the accuracy of predicting the cardiovascular disease. Hence, there is a need of a robust machine learning model for predicting the cardiovascular diseases at an early stage, which helpful to predict the patterns, correlations, and risk factors for better improvement of the patient outcome. Coming to the abstract, as I said, cardiovascular diseases is a heart disease. The cardio represents a heart and vascular represents a blood vessel, and these are the these diseases is a silent killer in the worldwide. And these days, automated diagnosis is required for quick solutions. So, in this paper, we have performed a comparative analysis on different machine learning algorithms, and my proposed model is extreme learning machine algorithm. And the comparative analysis of different machine learning algorithms such as SVM, Gaussian nerve-based logistic regression, ensembling model combining of two random forest and logical regression. And the next algorithm is XGBoost. And the proposed model is extreme learning machine algorithm is fetched a better accuracy compared to the existing algorithm for better prediction of the heart condition. And the methodology used here is the proposed methodology is based on the deep learning and the machine learning approach for predicting the cardiovascular disease. And the steps involved in performing this pre-processing, feature extraction, model training, validation, and performance evaluation. The first step is data acquisition. Here, the Calvin land dataset is used for training and evaluating the model. And then pre-processing is performed to eliminate the noisy data and unwanted data and prepare for the model to train. And data is split into training set and testing set in the ratio of 80 to 20 ratio. And then feature selection is performed based on the pre-trained models such as SVM and such as machine learning models and proposed model. Coming to the first model which I have used is support vector machine. It is a supervised machine learning algorithm for classification as well as regression model. And this model is used for finding a boundary that best separates the data points of different classes in a data set, which helps you predict whether the patient is at risk of cardiovascular diseases or not at a risk of cardiovascular diseases. And the next logical regression algorithm is implemented, and it is a machine learning algorithm, and it is also for a binary classification and based on the input features, and it calculates the probability of an event happening based on the formula called sigmoid function and makes prediction and based on that probability. And next one is a Gaussian naive algorithm, and it is a classification algorithm based on the it is implemented based on the Bayes theorem, and it performs assumptions features which are independent of each other and the continuous features that follows the normal distribution. And the next one is the ensembling algorithm, combination of random forest with a logical regression. And by combining the strengths of the two algorithms, which improves the classification performance. And here the random forest is first implemented, and with that prediction, next logical regression is applied for predicting final prediction. The next one is XGBoost, that is extreme gradient boosting algorithm, and it is a machine learning algorithm for classification and regression models, and it is used to build a new a sequence of decision trees. In each building of a new tree, it corrects the errors of previous ones and predicts the final results, which helps to minimize the error and during training. The proposed model is extreme learning machine algorithm for prediction, and this algorithm is a fast and efficient machine learning algorithm, and it consists of a single hidden layer of feed-forward neural network. Unlike to the traditional feed-forward neural network, it eliminates the iterative optimizations or a gradient descent and backpropagation techniques. And this structure has three layers. The first layer is the input layer, which takes the inputs as a feature, and the second layer, which contains the random initialization of weights and bias, and the third layer is an output layer, which produces the predicted values. In the training step, the first is the random initialization. Each input sample of first layer is given an applied an activation function and random assigning of a weights, and it is multiplied with the input sample. Then bias is added to the connections between the input and hidden layer. So these weights are fixed and need not to be updated during training. And then finally it produced a high dimensional feature space. Then it calculates the output weights by minimizing the error between the
Sorry to
predicted
interrupt,
and the
ma'am,
hidden layer
but you
actual
have
output.
1 minute to conclude.
Okay, sir. So this is the flow diagram. So I've taken a collinear data set and then I performed a pre-processing. Then my architecture is ELM, and then I've classified into whether the patient is at the risk of a cardiovascular disease or not a risk of cardiovascular disease. And this is a architecture of implementation. And these are my results. So I compared the existing machine learning algorithm with the proposed machine learning or proposed model extreme learning machine algorithm, which given a better accuracy compared to the existing one. My conclusion is, so I have performed a comparison with the existing machine learning algorithm with extreme learning machine model using a Kalani dataset, and this model given a better accuracy and precision recall and F1 score. In the future, this implementation can be used for ensembling deep learning methods as well also different diverse data types, and integrating with the ELM can be integrated with the deep learning model can facilitate more accurate results for early diagnosis and risk assessment. Thank you, sir.
Thank you, ma'am. I request session chair, sir. Sir, do you have any questions?
Yeah, ma'am, can you elaborate more on your proposed ELM model? What is the your contribution so your result is better than existing?
So I have used a ELM model for fast training. And in this ELM model, we have used only single hidden layer, which helps where it performs linear equation calculation, which helpful for solving, which helpful for fast training, and instead of it using iterative optimization. And here I'm using this model which help you to assign a random weights and biases, so that there is no need of hyperparameter tuning. And by doing this, which it achieves a good optimization, good generalization performance.
Okay, and what type of pre-processing you did in your experiment?
So I've removed the missing values, and I have eliminated the non-numerical values.
Okay, thank you, ma'am.
Thank you, sir.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Karthik K for the paper title A Gesture Translation for Hearing Impaired Individuals in Emergency Circumstances. I request the participant to kindly proceed with their presentation.
Yes, sir. Thank you for the brief introduction, sir. So I will share my screen, sir.
Yes, sir. Now you can share your screen.
Yes, sir. I hope that my screen is visible, sir. Shall
Yes,
I
sir. Your
start?
screen is visible to us.
Yes, sir. Thanks for giving given this opportunity, sir. Myself, Karthik. I'm going to present the paper research article titled as a gesture translation for hearing impaired individuals in emergency circumstances. I'm going to introduce my co-authors like Dr. P. Pandya and Dr. Tanavel, and then Mr. Sengol Rajan, and then myself. And then I'm going to tell our objective, what is we are going to do in that particular research. We are going to identify that sign language for helpful for that deaf and dumb peoples. Normally the sign language is going to be helpful for that deaf and dumb peoples to communicate with that real world peoples. So normally that sign language is not able to difficult that normal peoples. So we are going to analyze that how we are going to give the technical solutions for that signed languages, because it is easily to understand that the normal people, then only the different people is able to communicate with that other people. So that is very helpful for that. That is our objective to do that research articles. So in that we have to be using for that computer vision. So our research article we are going to take in for that computer vision and then neural network concepts to implement these research articles. So first thing we are going to analyze that gesture translations, how the
So
people's
your slides has been stuck. Like we are only able to see your first page.
1 minute, sir. Once again, I am going to share it. Sir. The screen is moving, sir.
Yes, sir. Now it is moving.
Yes, sir. So we are going to try to using that image processing methodologies, and then neural network technologies to identify the gesture translations. For that, when normally the deaf and dumb peoples will be giving that some gestures, we are going to analyzing that gestures with help of this video and then audio images to convert that gesture images and then technologies to that normal verbal communication methodology. This is what we are going to be done in this particular research areas. Next, we are going to do some research related works on that particular researches. So we have to do some relative papers. What are the things they have earlier researches they are going to doing, and what are the methodologies they are going to done. We are going to analyze that, and what are the demerits and the demerits will be having that. We are going to fine tune that, and we have to rectify some problems, and we are going to give some accuracy to that. Example, we have to taken that Arpita and then Helder. They have to propose that some methodologies like real-time vernacular sign language recognition using media pipe and then machine learning methodologies using the technologies they have to mentioning that support vector machine. So it's having some merits in that it's having the efficient, precise, and then it's having that robust methodologies. But it having that some demerits like large data sets, and then it's going to be having that complex, complicated methodologies. Likewise, Haman and Lumen, they have to propose some technologies for this the problems to addressing this. An efficient two-stream network for isolated sign language recognition using accumulated video motions. They have to using that long short-term memory methodologies. It's going to be given that some efficient and then accurate way, but it's having that some relays on that video in the abstractions. Likewise, we have to referring that some more papers. Based on that, we have to identify that some related work gaps. We have to find out that papers. First thing, they have to analyze that hardware control to detect that hands in that, is a difficult one for that earlier proposals. So we are going to addressing these problems on our researches. Next, hand segmentation and then segmentation accuracy. We have to find out that hand segmentations and then accuracy level of that hand segmentation before that during that gestures we are easy not going to be easily identified, and it's having some problems on that. So these are the related works gaps we are going to finding in the earlier versions. So now we are going to try to address these problems on that. So next we have to see that this is the proposed system architecture of our product. First thing, we are going to be analyze that we are trying to train that gesture, finger gestures. Normally the finger gestures, they having the different people using some gestures for that sign languages. They likewise, this is the guest languages. They have to mentioning that A and B, C, and then D. So likewise, they have to mentioning some gesture for that hand symbols. So we have to be train that model for that gestures. What are the gestures will be available? Based on the gestures, we are going to producing that alphabet. First thing, we are going to train that gestures based on that. Next, we are going to analyzing that videos. We have to capturing that images. After that, we are going to doing given that images to that convolutional neural networks. Based on that CNN results, we are going to matching that, classify that. Okay, what is the gestures that images during the producing that? We have to mapping, and then the trained models will be analyzing that. It's going to be matched with that our existing trained sets. Based on that, it's going to be producing that results. So this is the way our proposed system architecture will be working on that. Now we are going to working in that elaborately they describe of that how the our proposed system will be working. First thing, we are going to be analyzing that hand image. What is that hands proposed gestures there people will be given that. We are going to analyzing that. We are going to posture that gestures, and based on that we are going to train that model. First thing, we are going to analyze what is the level of that points, and how the image fingers are normally the hands movements will be there. We are going to analyzing that. After that, we are going to doing that binarization method using the computer vision model. Based on that, we are going to analyzing that further movement sequence of images. We are going to be analyzing that through the videos. We are going to analyzing that sequence of images. How we are going to detecting that what is the kind of postures the people will be given into that. After that, we are going to analyzing that what is that kind of symbols they are going to given into that. So the particular images we are going to analyze is using that a region of interest, that means ROI. This is the more thing, the technology we are going to identify with that what is the kind of symbols the peoples will be going to be produced likewise. So we are going to analyzing and that regions where is the points will be available be through that pixels. We are going to identify through the help of only the machine and learning models, and the models are going to be analyzing that. Next, we are going to, based on that finger regions, we are going to mapping that existing training model sets. We are going to analyzing that
Sorry to
what is the
interrupt, sir.
But you have 1 minute to conclude.
Yes, sir. Yes, sir. So we are going to be classify that what kind of images we are going to be using, that what is kind of postures they are going to be running. Next, we are going to find giving that results based on that Excel classification. So they are going to classify that what is the kind of postures they are going to mentioning that. So we are going to given that results as a verbal communications. So next we are going to see that this is the implementation part of that. So normally the people's given that fingers or signs means we are going to analyzing that regions of that. So what is the region? The regions will be available in that each and every fingers. Based on that, we are going to be analyzing that. That ROI model will be analyzing that each and every regions of that particular images. Next, we are going to analyzing that models. That classification will be predicting that the sign is going to be the equivalent to the text of B. Likewise, we are going to be analyzing that based on that the region of indexes. Based on that images, the regions will be identified. It's going to be mapped with that existing models. Based on that, the classification technologies, they are going to classify that this kind of verbal text they are going to given that. Likewise, we are going to analyze it. So example, this is the another text we are going to process. Likewise, this game symbol will be we are going to given that means it's going to be identified that regions. Based on that, it's going to be producing that text. So we are going to analyzing that accuracy of that. So earlier versions they are going to given that 70 to 80% of accuracy in that earlier research methodologies. Now we are going to trying to using that models, we are going to producing that results in nearly 90% of accuracy. So our ultimate goal, we are going to do that in futurely, we are going to find it with that some drawbacks we are going to facing in this particular research areas, like with the sign variabilities and then lightning conditions and then camera angles we are going to facing that. So we are going to overcome these issues into that upcoming future works. So this is the way we are going to do that and that articles, but in our research articles it's going to be producing that good results compared to that earlier versions. Thank you, sir.
I request session chair, sir. Sir, do you have any questions?
Okay, for your experiment, which data set you used, or have you prepared your own data set?
Yes, sir. We are going to using that Kaggle data sets, downloading some image data sets from that Kaggles. After that, we are going to using some our own real-time data sets also. We are going to try to prepare and given that inputs to that users. So the convolutional neural networks that's going to be analyzing that layers. It's first thing we are going to find out that input images during that real-time captures. After that, it will given to that convolutional layers. It's going to be move on to the convolutional layer. On the convolutional layer, it's going to find out that, and then pooling methodologies that's going to be identified. That after that, it will be given to that fully connected layers. So based on that fully connected
Okay.
layer.
And okay, and how you compare your results with the existing approaches?
In that existing methodologies, that is support star machine and then k-means nearest neighbor algorithms, we are going to analyzing that surveys and then literature works. They are producing that results of 70 to 80, but based on that accuracy levels. In that our is CNN based models, it's going to be given that better accuracy results for that earlier version. It's going to given that better accuracy for that k-means nearest and then supporter star machines to that. That particular CNN based is producing 90 over that 90% of accuracy compared to that existing models.
Okay. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you for giving this opportunity, sir. Thank you.
Thank you, sir. Now we are moving towards the next presentation. For next presentation, I would like to call Shivani M for the paper title, A Study on Revolutionizing Healthcare, the Future of Management Systems in Patient Care. I request the presenter to kindly proceed with their presentation.
Yeah, good morning, sir. Good morning, everyone. My name is Shivani. So today I'm here to present healthcare management system. So I'll present.
Ma'am, your screen is not visible to us.
Yeah, good morning, everyone. So here, the project healthcare management. So firstly, we already have seen many traditional healthcare management system. So here we will implement project where we have used and JDBC. So here, as we can see, this the integration innovation tools like AI, big data, and telemedicine into healthcare frameworks to enhance efficiency, accuracy, and accessibility for both patients and providers. And the main objectives of these particular project is that it provides high quality medical facilities in small towns with limited access to specialists. So here in this, patients do not need to travel so long, so they can take this it is accessible everywhere, so there's no particular, like, it's cost efficiency. And also with that, it ensures a user friendly interface for seamless adoption by all users, and deliver cost effective, as I said. And it support regular patients by minimizing the need for travel checkups. And right now we already have so many projects like this, but it actually lacks few points, such as platforms like Tata 1mg offer online doctor prescription services, but they fall short when it comes to diseases requiring long-term treatment such as cancer and all. So also some applications suggest nutrition-based products based on the symptoms for their sales, but at the same time, those sites do not give proper prescription. So this is the existing systems we already have it. And in this particular healthcare management system, so this is we have proposed for hospital to assist patients in small towns or elderly individuals. Also with this, the particular project that we've done, it's tech friendly. You don't have to be very advanced in technology. It's tech friendly, with that elderly friendly, so old people can also use this. So as I said, yeah, elderly individuals reliant on hospitals for regular treatment. So this system enables online prescriptions with specialists at scheduled time. So you can also use like appointments scheduling. And with that, additionally, it allows patients to securely store and organize medical reports on the portal, eliminating all hassle of searching for them. And if you see the key features of the project, as I said, it's appointment booking and checkup through the chat box. There's a chat box option as well, and then online doctor's prescription and patient lab report. So where you can upload all your diagnosis information and the patient's history, and there's one help desk as well. And with that, we've used database for this. So we've used MySQL. So as you can see, is the here diagram. So here we have patient table with that appointment, diagnosis, and doctor. And so the thing that we've done here is we've taken 1 minute. So here, as you can see here, the login page of this particular thing. So if any user is a new user, then you can go to the sign up page. So in the sign up page, there's you can upload your full name, username, and password. And if you forgot the password, there's one more option for that. So where you can just forgot password. And when you once you log into the account, you could see all the homepage like this, like manage patients and manage doctor, manage appointment scheduling, diagnosis information, and the information about the hospital, like clinic, and the logout button. And there is here you can see this is the diagnosis. So 1 minute. This is the patient ID. You can add all the patients over here. And then with that, here is the patient ID diagnosis information. So all the symptoms, diagnosis, medicines, all you can put it here. And with that, we also have a manage appointments. Here, the doctor, this is the doctor ID. So all the doctor's details will be stored over here. And this is the appointments. So doctor and patient, doctor could see all his patients over this. So date and timings will also available over here. And here is the results that what we have gotten, all the databases results. And yeah, these are the technologies and tools we've used in this particular project. That is, for the front end part, we've used Java Swing, and for the back end, we've used Java. And for the databases, so the management is DBMS that we've used is MySQL with the connection now database connection. It is JDBC, and the libraries or the MySQL connector J we've used. And with that, the tools with IDs that we have used are IntelliJ and along with NetBeans. And for that, MySQL we've used 5.5 version. And as you can see here, the advantages. So in the advantages section, we have it's again the cost reduction, improved patient outcomes, increased efficiency, better data management, and it is improved communication. So it makes easier for patient and doctor so to communicate and enhanced patient experience. And so the limitations who are here, like the demerits of this project is, as you can see, doctors will be available during the free hours of their schedule. So appointments has to be done. So that is one thing. And then normally appointment takes 10 to 15 minutes. So it's not like it won't happen it very sooner. So this takes a little time. And with that, in this way, in normal a doctor can check up to 4 patients in an hour. So there's a limitation of patients checkups as well. So we can estimate 12 to 14 patients got checked in a day. So like that. And to overcome this shortcoming, we will add as many as doctors. So we have to add more doctors and the hospital to make available for patients. And yes, the finally concluding the project. So as we can say, this healthcare management system is a robust and efficient solution that digitizes patient records, doctor details, appointment scheduling, and diagnosis management. So also, this project modernizes healthcare operations, improves data accessibility, and provides strong foundation. So for future enhancements like AI-driven diagnostics, and also it is used in big data and mobile apps, cloud integration, and also it's as I said, it ensures efficiency and also it is reliable, and it's a accessible healthcare management. And also in the situations like COVID, this will prove safest mode for all citizens, kids, and the patients. Yeah. Thank you, sir.
Thank you,
Thank you,
ma'am.
everyone.
I request session share,
Yeah.
sir. Sir, do you have any questions?
Okay, so this is almost like as a web application. So can you tell me the what kind of security measures you consider in your application?
Yeah. Yes, sir. So basically here, only the user can see into it. So, uh, so there'll be data security for that. So only the user and the admin could see all the data sets, like databases stored. So and everyone can't use it. So that is and also with the like if a new user or even old user, for them you could just put into your like phone number. So in the phone number you can get the OTP there. So verification of phone number will be like that's one of the things.
Okay, okay, thank you.
Yeah. Thank you, sir. Thank you for the opportunity.
Thank you, sir. Thank you, ma'am. Now we are moving towards the next presentation. For next presentation, I would like to call Anmol S for the paper title Advances in Crop Disease Detection, a survey of machine learning methods. I request the presenter to kindly proceed with their presentation. I think so. The patient is facing some network issues. Let's move towards the next presentation. For the next presentation, I would like to call Ritu Singh for the paper title Implementation of Markov Chain in Aerial Refueling System during Russia and Ukraine War. I request the presenter to kindly proceed with their presentation. Move towards the next presentation. For the next presentation, I would like to call Ritika for the paper title Navigating the Complexities of Image Deblurring Techniques, Challenges, and Real World Applications. I request the presenter to kindly proceed with their presentation. Now let's move towards the next paper. For the next paper, I would like to call Punguzali for the paper title Predicting the Risk of Citywide Traffic Road Accidents Using Deep Learning Techniques. I request the presenter to kindly proceed with their presentation. Ma'am is fixing her issue. Let's move towards the next presentation. For next presentation, I would like to call Akash for the paper title Real-Time Traffic Management Using Deep Learning.
Good
I
morning.
request the presenter to kindly proceed with their presentation.
Good morning, sir. Good morning, everyone. Guys,
Good
can you
morning,
see my
sir.
screen?
Sorry, yet it is not visible.
Give me a minute. Uh, Excuse me. Hello.
Yes,
Hello.
sir.
I'll have to restart my application. Can you proceed with the next one? I'll come back in a minute.
If you want, I can share instead of you.
But I have a PPT, right?
Okay, let's move towards the next presentation.
I'll join. I'll be joining in a minute. Yes.
Okay, no problem, sir. Let's move towards the next presentation. For the next presentation, I would like to call Pradeep P for the paper title Smart Agronomy, Deep Learning Powered Disease Detection and Micronutrient Management in Sugarcane Crops. I request the presenter to kindly proceed with their presentation.
Good morning, all. I'm sharing my presentation.
Yes, sir.
Yeah, is it visible?
Oh, yes, sir, it is visible to us.
Yes. Good morning, session chair and all of you. So today, I'm going to present here the paper that is on the smart ergonomy, that is deep learning powered disease detection and micronutrient management sugarcane crops. So under this one today, we are going to discuss the abstract, then introduction, then objective literature survey, and methodology distribution and evolution matrix and benchmark dataset that use and research gap identified and the future direction and the conclusion. So first abstract. So in this paper, basically the exploration of the potential of the deep learning in the sugarcane agriculture by addressing the critical challenges of the disease detections and the micronutrient deficiencies. So employing the convolutional neural network and the RNN, the research evaluates with the some hybrid models like ResNet, then VigiNet to achieve the high diagnostic precision in the diseases. Then, despite of this advancement, the issues like the limited data set and the real-time application persist, and that causes the necessity to having the robust solution in this particular field. So, this work will be proposing the some comprehensive framework that should be having the integrating hyperspectral imaging and the tailored with the ergonomic recommendation to enhance the crop productivity and the disease detection early and the macronutrient deficiency as well. So, introduction, as we are considering, the India is a country where the sugarcane production is approximately the 3.5 million ton per year, as well as the based on the sugarcane, there is a vital product of the global economy, as well as the sugar and sugarcane products, as well as the bioethanol production in consideration with the energy that should be considered as the importance of the sugar. As the challenges, there are the some type of the diseases, mainly we are saying the red rot, smut, and the causing the micronutrient deficiency. There is a production declination by the 40 to 50% in the sugarcane. That traditional approach for detection, we are having the manual inspection then labor centric as well as the lab analysis that causing the some tedious will be there, as well as the more error prone and the slow process for the diagnostics and the detection. So the technological advancement that can be having the impact, why not that can be used in this particular one. So deep learning offers the precision as well as the efficiency in the diagnostic with the focusing on the automation as well as the scalability in this particular field. Now, the objective of this particular paper is to comprehensive review of the deep learning technique for the disease and micronutrient deficiency detection in the sugarcane crop. Then evaluation of the deep learning models like CNN, RNN, and the hybrid architecture that has been yet used. Then identification of the research gaps and the seeing the future direction for the enhancement. So again, the last objective of this one to propose the real-time diagnostic framework for the crop management system. Now, under the literature survey, we have followed this process. So, collecting the data collection will be there. So, for that one, we have reviewed the 50 plus article from the 2015 to the 2024 from the several reputed journal like Scopus, IEEE, Explorer, and the Google Scholar database. And their article selection criteria we have selected based on the peer review article, and that should be relevant to the sugarcane and AI-based precision agriculture sector. Then technical techniques that we have evaluated and reviewed, that is CNN, RNN, ResNet, and the hybrid model. So in that one, image processing as well as the segmentation and feature extraction also taken into the consideration. So here is the some machine learning technique or the models or algorithm that we have studied under the literature survey. That is under three categories: supervised, unsupervised, and the deep learning. So under the supervised, like logistic regression, linear regression, ANN. Under the classification, ESPM, random forest, KNN, CART, ANN, like algorithm we have gone through the literature review. Then under the unsupervised learning, we have seen the clustering algorithm like K-means, WMAX hierarchical clustering will be there. Then for dimensionality reduction, we are having the PCA, SVD, PLSR. And for deep learning, we have the convolutional neural network as well as LSTM, RNN, WACNN, RCNN. This algorithm we have considered. So based on this particular literature survey, so we have gone through the several research papers. So here are some among that one and their methodology use and their gaps. So first paper, that is Pelgam ETL in the 2019, that is using the convolutional network having the limited practical application in the as well as the limited data set will be there. Then metal CNN using the CNN technology restricted for the sugarcane leaf images. Then third one, that we use Singh et al., that is CNN at the fast integration and validation challenges in the diverse agriculture environment is a gap. So next, that is Ribro et al., that using the random forest neural network LIME technique is then one. The gap is lack of clarity in the model prediction. Then next, Alamin et al., 2019, that using the again CNN. Mostly the lot of the deep learning technique using the CNN in the upcoming papers. So based on that one, dataset limitation as well as the crop specific data is not available under the next one. Then difficulty in handling the complex background under the paper. So next paper as well using the some algorithm like say AlexNet, GoogleNet, VGG16 with the SPM, that is integration of the ADL and ML as well. And the some IoT based approaches like deep learning on the Raspberry Pi, the neural network deep learning that has been coined by the different methodology. The gaps basically dataset centric specific limitation, then limited scope of feature extraction will be there, then high computational complexity, limited feature interpretation, and the restricted for the nutrient deficiency only. So based on that one, the methodology distribution, we have found out the deep learning having the 55% under the technique included, that is CNN, RNN, LSTM, GRU, DBM, that can be providing the using the having the capability of handling the large data set as well as the complex data structure. So particularly for the feature extraction and the classification. Then machine learning 20% uses will be there. So that will be again having the basic structure such as decision tree, SVM, then k-nearest neighbor algorithm, that having the their simplicity as the effectiveness working with the tabular data format. Then hybrid approaches where both deep learning and machine learning algorithm using that having the percentage 25% among the paper we have referred. So that incorporated the both technique that is having the deep learning and the machine learning. So here is a percentage, the pie chart should be there. So that clearly signifies deep learning will be using right now mostly, but hybrid approach having the 25% only and machine learning having the 20%. Based on that one, the evaluation matrix for the studied and used, and that can be widely accepted for the accuracy purpose. We are having the some attributes like say true positive, false negative, false positive, true negative, and the precision. So based on that one, the recall rate we are going to calculate. So the ratio is correctly classified again the attacks instance for the all actual ones, and the false alarm rate, that should be the ratio incorrectly predicted attacks to the all actual normal instances for the disease detection. Based on this evaluation matrix, again we are going to have the true negative rate, that can be the ratio correctly classified against the normal instances to the or the normal instances, and the accuracy detection will be there the ratio correctly classified instances, that is both that is a normal attacks, and we can say the detection as well as the normal to the total number of instances. The metric useful when data is the balance actually. So F1 measure or F1 score, the harmonic mean of the precision and the recall, providing the balance measure of the considering both false positive and the false negative will be there. So based on this one, the benchmark dataset we are having the plant village dataset, that should be having the application of the plant disease classification, having the more than 500 and 5,400 labeled images, and then UAV hypersectoral based data images will be there. That is monitoring the crop health, having the high resolution spectral data will be there. And then next ICRACST agriculture dataset, that is having the crop resistance as well as the stress analysis of the crop. Basically, environmental and image dataset that has been combined. The environmental dataset will have some environmental
Sorry to interrupt, sir,
temperature.
but you have 1 minute to conclude.
Yes. Then Sentinel metasectoral dataset having the free access of the vegetable dataset, and the Kegel crop dataset having the 200 plus dataset label images. Now, research identified that scarcity of the sugarcane specific dataset as well as computational requirement will be there. Then variety in the field of condition, and the future scope development of the comprehensive dataset as well as enhancing model transparency and reliability, the integration with the farm management system. So based on that one, we are going to conclude that the study highlight the transformative role of the advanced deep learning and the machine learning technique diagnosing the diseases and the micro deficiency in the sugarcane crops. Despite the challenges such as the limited data set as the remote application constant, innovation like CNN, hypersectoral images, and hybrid models demonstrating the significance, advanced and promise in the future scope. So future research should be focusing on the creating specific data set as well as enhancing real-time usability and integration of the precision agriculture system to optimize the crop yields while ensuring the mostly sustainable and eco-friendly practices for the farmers. So this advancement will be empower the farmer for the more production as well as the sustainable sugarcane farming in the world. Thank you. So these are the references. Thanks.
Thank you, sir. I request session chair, sir. Sir, do you have any questions?
Okay, so this is a, survey paper. So can you elaborate more on research gap, because the in that slide you have not mentioned properly the gaps.
Actually, the research gap is that whatever the right now deep learning technology using, that will be considering on the limited data set. That is the first disadvantage. Mostly the hypersectoral images not considered, as well as the other factors that we are seeing, the environmental factor as well as the soil data that consider while considering the crop micronutrient deficiency in the sugarcane as well as the disease. So we are going to have the that means consideration of the real-time data as well as the more the specific data as well as the different type of the data that we are going to consider while doing the crop disease detection as well as the micronutrient deficiency. That is basically multimodal approach. Yes, sir.
Okay. And what about which data set you are trying to use in your research?
Right now, the Kaggle dataset we are having, as well as we are preparing our own dataset. That is a multimodal data. Not only we are depending on the images dataset, but also the other factors.
Okay. Okay. Thank you.
Thank you, sir.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Kalpit Soni for the paper title Unveiling the green potential of cloud data centers, a study on CO2 emission mitigation strategies. I request the presenter to kindly proceed with their presentation.
Screen is visible, sir?
Yes, sir, your screen is visible.
Okay. Good morning, everyone. My name is Dr. Kalpit Soni, and I am presenting our study title, Unveiling the Green Potential of Cloud Data Centers, a study on CO2 emissions mitigation strategies. I collaborated with Dr. Unnati Patel, Dr. Jamin Undavia, and Ms. Dhatri Rawal for this research. This work focused on addressing the environmental challenges posed by the rapid growth of cloud data centers. Data centers are crucial to the digital economy, supporting global giants like Google, Amazon, and Microsoft. However, their rapid growth comes with a significant environmental cost. By 2025, data centers are projected to account for 3.2% of global carbon emissions, and electricity consumptions could reach one-fifth of the global total by 2030. Our study investigates strategies to mitigate these emissions and reduce the environmental impact of cloud data centers. Carbon dioxide emissions are a major driver of global warming, leading to rising global temperatures, stronger typhoons, and dissatisfaction. Currently, data centers consume around 3% of global electricity. Without proactive intervention, data centers could have an outsized role of intensifying the climate crisis. This underscores the urgency of exploring energy efficient solutions and sustainable technologies. So, our objectives are to mitigate CO2 emissions, optimize energy use, and adopt green computing practices. Right. Cloud computing, as per the defined by NIST, enable pervasive access to share computing resources. It has reformed the digital world with its market size expected to growth, right, 832.1 US dollar billion by 2025. To address the environmental challenges, green computing emphasizes resource efficiency, energy minimization, and the adoption of eco-friendly technologies to curb carbon emissions. From 2015 to 2021, the number of internet users grew from 3 billion to 4.9 billion, and data center workloads increased by 260%. This surge, along with energy intensive activities like cryptocurrency mining, has driven up global energy consumption. By 2025, global data traffic is expected to reach 175 zettabytes, highlighting the need of more efficient data center infrastructure. Energy and CO2 trends. Energy efficient data centers are essential for reducing power consumption and environmental impact. Upgrading to energy efficient hardware, optimizing cooling systems, and designing sustainable infrastructure can significantly cut the CO2 emissions. These changes not only benefit the environment but also reduce operational cost. Green cloud computing strategies. Industry leaders are taking steps to incorporate renewable energy into their operations. Just 1 minute. Sorry. AW has invested heavily in solar and wind energy project. Just 1 minute, sir. Industry leaders are taking steps into incorporate renewable energy into their operations. AW has invested heavily in solar and wind energy projects in India, generating over 2 million megawatt annually. Microsoft powers 44% of its data centers with renewable energy and explore innovative solutions like underwater data centers through the project Naitik. Okay. Now, vendor contribution to green computing. Other industry players are also leading the charge. Google has operated carbon neutral data center for over a decade and aims for 100% carbon free energy by 2030. IBM has adopted green technologies for over 35 years, reducing CO2 emissions by 11.1%. So these all are the vendor involvement. Now, remote work and e-waste reduction. The rise of remote work post from COVID-19 has led to reduced commuting and lower fuel consumption, decreasing emissions, and additionally, digital tools like cloud storage and e-signature platforms have enabled paperless solutions, while cloud adoption has minimized e-waste generation. Challenges, okay. Some another user-centric strategies for green computing are Blackley, Zonbu Computer, Sunray Thin Client, Asus EPC, Fit PC, energy efficient storage, right? Virtualization and terminal servers, and power supply and management. Challenges and future work. Despite progress, challenges remain. Energy consumption and emission will rise as data centers grow unless efficient technologies are adopted. Managing large scale infrastructure sustainability is complex. So, future efforts should focus on increasing renewable energy use, advanced green computing research, and fostering collaboration between stakeholders like policymakers and industry leaders. So, to summarize, cloud data center play a critical role in the digital age, but a significant contribution to global energy consumption and CO2 emissions. Reducing their environmental impact require industry-wide adoption of energy efficient hardware, renewable energy integration, and collaborative efforts. I urge all stakeholders to prioritize the sustainability in designing and operating data centers to ensure long-term environmental benefits. Right? These all are the references. Thank you, sir.
Thank you, sir. Now I request session chair, sir. Sir, do you have any questions?
Okay, so what is your observation when you are saying the green computing? So, what is your observation overall?
Actually, now cloud is everywhere. So data center increasing day by day. So it impact on CO2 emissions. So if cloud vendors and the users, right, adopt some green tech concept, so we can reduce the CO2 emissions and right, it will all benefit to our environment also, sir.
What about the challenges?
CO2 emissions mean the environmental effect and the electricity consumptions in cloud data centers.
Okay, okay, thank you.
Thank you, sir.
Thank you, sir. Now we are moving towards the next presentation. For next presentation, I would like to call Anmol S for the paper title Advances in Crop Disease Detection, a survey of machine learning methods. I request the presenter to kindly proceed with their presentation. For next presentation, I would like to call Ritu Singh for the paper title Implementation of Markov Chain in Aerial Refueling System during Russia-Ukraine War. I request the presenter to kindly proceed for their presentation. Now I would like to call Ritika for the paper title Navigating the Complexities of Image Deblurring, Techniques, Challenges, and Real World Application. I request the presenter to kindly proceed with their presentation.
Hello, sir. I am not able to share my screen.
Ma'am, now you can share your screen.
Yeah. Is it visible?
Yes, ma'am, it is visible to us.
Okay, thank you. So myself, Rikita Choksi, and today I'm going to present the navigating the complexity of the image deblurring using like technique that what are the challenges and the real world application. So myself, along with my co-author Dev Parikh, Jai Parmar, Yug Panchal, and Dr. Sudhir Vegar, we are working collaboratively for this research work. So this is my outline that I'm going to present today. The main part is objective literature review, the methodology, proposed architecture, result, challenges and future work, and concludes. So basically, what is the image deblurring and what is the requirement of image deblurring? So nowadays we are capturing too many images that are having too many degradation factors. So first of all, the requirement of the deblurring is to recover the image with the better quality, and there are very conventional technique already available for the same, but when we are capturing the image, we are not sure what is the degradation factor, what is the blur type. So first thing is to find out the cause of the blur and then try to recover it. So along with the conventional technique, there are lots of advancement is available using the state of art technique nowadays using machine learning and deep learning. So with the help of this state of art method and the current trending model, I'm going to recover the corrupted images. So which is very useful in the numerous applications area like autonomous vehicle, medical, smartphone photography, and in our real life, that is the day-to-day life when we are capturing the image. So next, that is what is my main purpose. So the main purpose is that to obtain the good quality of the image by removing the blur type available that is in the corrupted image. Along with that, the degradation factor available. So based on the various category of the degradation, first find out the degradation factor and the cause of that, and then trying to apply the technique to recover the sharp image. So along with the traditional method, the state-of-art image deblurring method I have applied, that is the GAN model, Dibler GAN V2 model, and Vision Transformer. So based on this state-of-art technique, I am comparing the performance of this model, and I am also using the various data set available, that is the GoPro, Real Blur, and Height. So along with this technique, trying to find out what are the limitations and gaps available and trying to find out the performance of this model. So this is my literature review. So basically literature review I have studied, that is for the this three model, that is the GAN, Deepler GAN V2, and the Vision Transformer. So along with that, the starting with the convolution neural network, that is the model that is also used somewhere in the combination of this different model. So Popan et al. Has presented that Dibbler GAN based model for the blind motion deblurring. So when I say the various type of the blur available in the image, it is consisting of the motion blur, Gaussian blur, disk blur. So first trying to find out the type of the blur. So that is basically the blind image deblurring. So majorly I am focusing for the motion deblurring. So in first paper, the author has talked about how to recover the motion blurred images. Then how in second paper, the author has talked about the significance of the deblur GAN. After GAN model, what is the comparison between the GAN and deblur GAN and how it is able to improve the performance. Then in third paper, Zamir et al. Has talked about the Restormer, the fusion technique that is based on the transformer model. So based on that transformer model, how we can achieve the accuracy and the performance and how it is applicable to the deblurring task. In fourth paper, the co et al. Has presented that comparative survey of the conventional method along with starting from the CNN, GAN and the hybrid model. So from that survey, I have found out some models that I can apply for my research work. Then in fifth paper, the Zhang et al. Has presented a survey for the deep image deblurring. So specifically in that also the survey has been carried out for the different deblurring method. In next paper, the designing iterative technique for the image deblurring. So in that also they have done the survey of the various model, and based on that they have proposed the iterative optimization framework for the complex restoration task. In next paper, they have discussed for the GAN based model for discrete cosine transform, so which is also used for improving the quality of the deblurred image. So it is basically GAN based, but it is in the combination of with density loss. In next paper, they have talked for the deblurring for the realistic blur simulation. So they have used both kind of the blurry images for the training model, that is the how we can like reduce the gap between the synthetic blur image and the real world blur image. So based on that, they have trained the model for getting the better quality output image. In next paper also, they have used the GAN model for the fingerprint deblurring using the GAN model. So here the survey is basically for all the image deblurring technique, but they have, according to their application, they have provided some variation in the GAN model, as well as they have also used the CNN and GAN model. Later on, they are moving to the transformer and they are trying to integrate the different part of the encoding technique along with that model and trying to improve the accuracy. So in this, all the paper also, I would like to give in the brief that they have also used the CNN, GAN, Dibler GAN and transformer model based on their various application area and trying to improve the accuracy and trying to find out the comparative analysis how we are able to achieve the maximum good quality of the output image. So in this paper also they have used for the super resolution, but using it is also based on the GAN model. And the last paper in that also they have used the multi-scale CNN for the dynamic scene deblurring. So it is also based on the real world images for the motion blur. So this is my methodology that is I have applied. So the first one is the generative adversarial network. So in that it is using the dual component architecture. So it is using one generator and one discriminator. So the role of the generator, that is creating the synthetic image, and based on that it is trying to distinguish between the ground truth image and the sharp image. And
Sorry to interrupt, ma'am, but you have 1 minute to conclude.
okay. So basically in GAN model, sir, can I go to directly comparative of this technology? Okay, so the comparison of the methodology that I have applied, that is the GAN, Tipler GAN V2 and the vision transformer. So basically it is working for the deblurring, improving the quality of the better image. So these are the parameters based on which I have compared them. So the architecture in the GAN, that is use generator plus discriminator. In Dibler GAN V2, it is using CNN plus GAN, and vision transformer is totally based on the transformer. So the data set I have used for all these three models, that is the hide, real blur and GoPro image, which is consisting of the motion blur real image. So in some of the data set, it is using the motion blur image for the human object. In real blur data set, it is using the photo image that is captured with the DSLR and smartphone, and in GoPro dataset it is using the synthetic motion blur images. So based on the training of the model, I have made my architecture, that is first input image that is integrated and it is going to the Dibler GAN V2 architecture. Along with that, I have combined the encoder and iterative comparison is performed. Noise reduction is also done, and based on that, the training of the model, I have measured the quality of the output image. So these are my result. Based on the quality metric of the PSNR, I have compared the result for all these three methodology. So from all these three methodology, it is working fine for the deep learning V2 model, and that is for the GoPro dataset, in which we are able to achieve the PSNR value, and it is giving the it is giving the good PSNR value, that is 30.5 decimal. So these are the result for the vision transformer. So based on the starting epoch to 60 epoch, it is comparing the performance for the how training and validation is achieved. So it is indicating the consistent improvement over the 60 epoch. So these are the main challenges when we are working with the image deep learning. First of all, that is the dataset limitation. Then second one is the computational overhead, that is demanding for the high GPU and TPU for performing this training and inference. Then it is also like in future, it also can be combined the multimodal, that is the strength of the GAN and vision transformer can be performed together, and can be improved the performance of the quality of the image. So using the hybrid solution, we can work in the future and extend this work for the same. The main another concern is that the robustness. So when we are training the model, it leads to the overfitting for the specific data set. So when we are working for the real world blur images, we need to take care of the data set as well as the overfitting issue. If it is working fine for the training period, but it is not able to respond to the unseen data, then we cannot achieve the good result for the real world image. So these are the main challenges for this work, and for this specifically future work, I would like to extend the work that where I am getting the good result for the Dibler GAN V2. So based on that architecture, along with the combine of the vision transformer, the new architecture can work fine. So this is all the conclusion part where Dibler GAN V2 is working fine. So it is representing the significant improvement for the image deblurring compared to the conventional method. Then hybrid model we can apply, and we can also expand the applicability of this platform for the real world images as well as video processing. So these are the references that I have used for my work. Thank you.
Thank you, ma'am. Now I request session chair, sir. Sir, do you have any questions?
Okay, you applied the GAN. So how you compare your result with the existing, and on what basis you are saying your result is better than existing?
Sir, actually it is the pipeline. First, I have tried some conventional method, that is like starting from the image deblurring blind and non-blind type, and this is one part of the flow of that work. So based on the in this particular flow, I have compared the GAN, Dibler GAN V2 and vision transformer.
Okay, thank you, ma'am.
Yeah, thank you, sir.
Thank you, sir. Thank you, ma'am. Now we are moving towards the next presentation. And for the next presentation, I would like to call Pankaj Ali for the paper title Predicting the Risk of Citywide Traffic Roads Accidents Using Deep Learning Techniques. I request the presenter to kindly proceed with their presentation.
Sharing the screen.
Yes, ma'am, you're audible to us.
Sir, is the screen audible, sir?
Yes, sir.
Yeah,
Yes, ma'am.
visible. It's
The
visible.
screen is visible.
Thank you, sir. Thank you. So very good morning, one and all to present here. So I'm happy to present our paper titled Predicting the Risk of Citywide Traffic Road Accidents Using Deep Learning Techniques. As urbanization and traffic density escalates globally, road safety has become a critical issue. So in this work, we explored how advanced deep learning methodologies can provide an actionable insights for reducing traffic accidents and improving the urban planning. So the road accidents remain a significant global issue with urbanization exacerbating the risks. So this research employs the cutting edge technologies, various deep learning algorithms. We have adopted deep neural network, convolution neural network, gated GRU, LSTM to forecast the traffic accident risk. And all these performance have been, we have used the performance indicators such as means MSME and MSC and the bias and map. And mainly this is for, these are all the indicators for the forecasting models. So, and among these, we have found that DNN demonstrates the higher accuracy. So the World Health Organizations actually it reports over 1.35 million fatalities annually due to these road accidents, predominantly affecting the young demographics. So environmental factors like fog and snow amplify these risks. So this research addresses the gap in the dynamic and the accurate risk predictions by leveraging the deep learning techniques, enabling the real-time interventions such as route optimization and the driver alerts. And in this existing literature survey, it underscores the efficacy of the spatio-temporal modeling in traffic forecastings. Our work builds on those foundations, employing advanced pre-processing techniques and metrics like MAP and RMSLC to refine the prediction modules. So this ensures that the precision in identifying the accidents, hotspots, and underlying risk factors, setting the stage for the robust urban safety solutions. So the architecture of our model in first we proceed with the data pre-processing techniques to remove all the unwanted things, and then we apply the deep learning techniques because the quality input produces the quality output. And these deep learning approaches it forecasts the frequency of road accidents so caused by different vehicles. And these are the techniques we have applied. So the architecture, we have the traffic accident data sets we have taken, and that is we have done the pre-processing, data cleansing, data smoothing, and certain transformation. And then we have in the computation layer we have applied 4 different deep learning time series forecasting modules. And in user access layer we have predicted separately for the car and the number of truck accidents and the bus and in general, so the other vehicles and all these things. So this methodology it relies on the traffic accident data sets for the risk forecasting purposes. And the in this data set we the inputs the accidents date based on the date, time, and GPS coordinates. These have been the taken for our analysis. We have incorporated 4 deep learning modules for predicting the cars and buses and various vehicles. And and in this, out of these, as DNN has provided a better result, more accurate, we have just given the detailed architecture for the for our core methodology. So at the core of this methodology, in the DNN algorithm, the renowned for is high adaptability in processing the complex data patterns. So this slide outlines the algorithmic framework, emphasizing its iterative learning processes and its role in outperforming the alternative models and predicting the accident risk with precision. So this is an architecture for the DNN. And we have just compared the results with the mean square error and the root mean square error and absolute mean square error, as well as we have just proceed with the bias because it's an error predictions, the differences between your actual and the predicted. So even the lower bias and the higher bias, it varies the results. So we have counted that particular metrics also in our research to find out the better model. So map, mean, absolute percentage error, and all these metrics we have considered for analyzing different vehicles. So the results, the performance evaluation for deep learning techniques for the general road accident prediction is given. So, and in this case, the error rate for this DNN is very minimum when compared to the other models. And then we have run the algorithm for predicting the bus accident predictions, and then car accidents and trucks. So we have considered run this model for 4 different types of vehicles. So, and all these are the results for the GRE in deep learning and CNN and LSTM. In the conclusion part, so our findings reveal that the transformative potential for the deep learning in traffic risk predictions, DNN leads in accuracy, while the GRU excels in reliability. So the in future, the integration of such modules into intelligent traffic systems can significantly mitigate the accident risk, fostering safer urban environments. So this study may serve as a blueprint for further advancement in predicting the traffic analytics. Thank you, sir.
Thank you, ma'am. Now I request session chair, sir. Sir, do you have any questions?
Okay, so you use the different deep learning approaches.
Yes,
So
sir.
what kind of new thing you added from your side? Then you are saying this
No,
is the
sir.
performance is better than existing.
Sir, first we actually this is one part of our work. Actually, we are doing the urban planning, overall data analytics for urban planning, traffic congestions, and other things. So previously, we just want to run through different algorithms to find out which is that, and now we are the next work we are integrating both the hybrid models of this DNN and GRU combined together. Actually, the next work currently we are doing on the CO2 emissions and the uh, uh, energy efficient algorithm. So this will be the foundation of our work.
Okay, and what kind of pre-processing you did?
So we have just done with the first we have done with the cleaning and the normalization. We have just applied with an normalization here, sir. Z-score transformation for providing that normalization.
Okay. Okay, thank you, ma'am.
Thank you, sir.
Thank you, ma'am and sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Akash for the paper title Real-Time Traffic Management Using Deep Learning. I request the presenter to kindly proceed with their presentation.
Hello,
Hello, sir.
am I audible? Hello?
Yes, sir, you're audible to us.
Okay. Can you guys see my screen?
Yes, sir, your screen is visible to us.
Okay. Okay, good morning, guys. This is Akash. I'm going to present this paper about real-time traffic management using deep learning. This paper is written by me and my co-authors, Anugrah, Govin, and Ayush. So this topic is about traffic. As we know that the number of vehicles are increasing day by day, and the traffic condition moves to another level, and we face a lot of problems. Apart from time, we face problems like pollution, petrol expenses, etc., just because of congestions. So we have come up with an approach which will help us to give a solution to reduce congestion. We cannot say that we can exactly mitigate it, but we can reduce the congestion. So the problem basically lies in traffic. So the solution we have come up with comprises of a object detection algorithm. This is YOLO. A YOLO model is a already trained model which can detect about various objects. So we are going to use this to detect the number of cars we have, and also use various other factors like the road length, the number of cars, the time of the day, means which time it is, and all other factors, to give it to a model which will predict the signal time for which the signal should run. For example, if I have 100 cars and the road is a bigger road, so it is expected that they all will pass by the signal in some 20 to 30 seconds, right? So we have generalized this thing. We have collected data, we have collected data about roads, about structures, about times, etc., and then come up to a conclusion, to a model which will tell us about the number of seconds for which a signal should run, so that it will reduce the congestion. So basic methodology lies: first we have collected data, then we've used the object detection algorithm YOLO, and then we have given all the data to a deep learning model which will predict us a timing. And then we have a different concept of synchronization of signals. Now think about this: what if the four sides of signal start coordinating with each other? If this happens, they can talk to each other and minimize traffic. I'll let you know with the diagram. This is the data we have collected: the seconds required to pass vehicle, the number of vehicles which are to be, the number of vehicles standing at the time, the current time. We have divided time into slots: 9 to 12, 12 to 3, 3 to 6, 6 to 9, because as we know, the office times 9 to 12 and 6 to 9 have a high traffic. Also, we have divided our data features into weekend and weekdays. We have a greater traffic on weekdays, weekends. Road types, we have divided road types into three types: a larger road like a highway, a smaller one, and a normal road. And then we have calculated traffic length. So using this data, if we give this data to this deep learning model right here, it will give us a prediction of how much time or how much seconds the signal should run. So this YOLO model is a basic model. It is already trained model. You can use it. But the main feature we are introducing through this paper is this signal level coordination. Now we many times see that the signal time isn't sufficient for all the vehicles to pass. For example, there are a lot of
Okay,
vehicles.
so sorry to disturb, but your screen is not properly visible. Your first page is only I can see.
First page is
Introduction. Can you reshare?
yeah, give me a second. Can you see the slide switching? Hello?
Sir,
Hello?
it's still sharing.
Hello?
Hello, sir. It's still sharing. We are waiting for it to be shared. It's loading actually.
Actually, to me, it shows that it is already sharing. Give me a minute. Now, can you see? Hello?
Sir, are you able to see the screen?
No, no.
Karthik sir, I've sent you a PPT on this chat. Can you give the presentation? Sorry, can you show the PPT for me?
Yes, sir. No problem. Can you just resend it to me?
Give me a second. Yeah, I've sent you. Hello?
Yes, sir. I have shared it.
Okay, so should I start again or start from the point where I left?
You can start from the point where you have left.
Okay, okay. Can you open the data part, that the Excel that is shown below? Okay, okay, okay.
This
Yes.
one.
Yes, this one. So this is the data we have collected to predict the timing. So as we know, these are the factors on which a model will train on, because this is the factors on which the time depends upon. Because if the road is smaller, we'll need more time. Because if the vehicles are more, we'll need more time. If the daytime is odd timing, we'll need lesser time. See, considering all these factors, we have trained a model. This data we have collected by ourselves, because I couldn't find a data as per our needs on the internet, or on the Kaggle, or on anywhere. So next slide. This is the basic architecture. Using cameras, we are going to record and predict the number. Calculate the number of cars using a YOLO model. This will be real time because this model is comparatively faster. It is as it is already trained. Next slide. So I was talking about this last time. So what if all the sides of signal start talking to each other? For example, if one side of the signal doesn't have any vehicles, but still the time is running, so this wastes the time for all the other sides, right? So if using cameras we can detect the number of cars that there are no cars, we can directly shift the signal or skip the signal. So this coordination part and this real time prediction part will help us reduce congestion by a lot. The exact metrics I do not have yet, but after the implementation is done, I think it will benefit the traffic problem and also reduce the congestion and give us a bit of advantage with petrols and environment as well. Next. This thing, the ambulance part is, let's say, a side advantage of this model. As you know, we can also we can detect vehicles. We can train the YOLO model to specifically predict ambulances. So as I was talking about, if the signals coordinate with each other, so if there's an ambulance on one side, we can just skip the other signals and just go to that side and start the signal with that side, because going off the ambulance is more important. So yes, next slide. Future scope. We think that this system of predicting time can be used with VANETs. VANETs means vehicular systems, which are now into works, because as we know that every vehicle has a mini computer inside itself. So if we can connect these systems to VANETs, it will be very important and useful, as we know that we are approaching a world where we called Internet of Things. So if we connect this with VANETs, this will help us predict and reduce condition using various different methods and using better techniques as well. Next. So conclusion. So this model uses a synchronization process, a deep learning model called as YOLO, and other factors like road types and number of cars, traffic density, etc., to help us tackle traffic congestion. Thank you.
Thank you, sir. I request Session Chair, sir. Sir, do you have any questions?
Yes, can you elaborate something about your contribution?
Okay, my contribution. I actually have collected the data, and I've trained the model. The accuracy as of now I'm getting is 70%. This is bad because the data is taken by us people, right? Us authors. So everyone has their own techniques, own way. So it is not actually a automated process, right? So because of that, we cannot get good accuracy. And after that, we'll be working on the synchronization process. So as of now, the model is ready.
And how you compare your result? What are the different performance evaluation parameter you used?
Okay, so see, as of now, I don't know a proper technical parameter, but first we'll start by surveys, because see, if I implement my method somewhere or at some place, so if we talk to people who regularly cross those streets, who regularly go using those roads, we might be able to understand that okay, this model is working. But when it comes to traffic, we cannot exactly measure, okay, the traffic is less, okay, the synchronized is good. So I guess surveys is a good measure to see if the model is actually giving results.
Okay, thank you.
Thank you, sir. Now we are moving towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the ninth version and all the previous eight version of the conference. We'll be happy to have you in 10th version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the paper have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTCS 2024. I also thank our session chair, Dr. Deepak Timane, for chairing the session. Sir, this is a token of appreciation from GR Foundation and partners for chairing the session. Sir, I request you to please address our participants.
Yeah, thank you. Thank you. All researchers has given the very good presentations, and wish you very best luck for your future research. Thank you.
Thank you, sir, for such kind and wonderful words. Now I request everyone to turn on their cameras for a quick virtual snapshot of the conference. Thank you, everyone. Thank you, everyone. Stay safe, stay connected. Meet you in 2025.